Not a good thing to do. Undo. Okay, I'll leave it there. Okay. So now I'm going to calculate. I'm going to use the right hand side tool right now. So we're going to find the principal plane now, right? So the principal plane over here is 2 theta p. So from point Y, rotate to theta 1 or sigma 1, okay? You can also rotate from point X to here. This is also 2 theta p. Either one you choose, the answer will be the same. All will have an anti-clockwise rotation. I repeat again, all will have an anti-clockwise rotation. Okay, so how to find tangent 2 theta p? So we are now going to calculate the principal plane. Okay, we are now going to calculate the principal plane. So tangent 2 theta p is equal to, you can see the numbers, right? 20 divided by 30, right? So theta p is equal to 20 divided by 30 inverse tangent divided by 2 is equal to 16.8 degrees. Right, 16.8 degrees rotating in an anti-clockwise direction. Okay, so let me do it again. 20 divided by 30 inverse tangent divided by 2. Okay, 16.8 degrees. So that is our principal plane. Okay, we have found our principal plane. But what does it actually means? Okay, what does it actually means? Okay. So now we are going to draw, okay, our element that's rotated clockwise by 16.8 degrees. Okay, so we're going to draw this now. Okay, so now we're going to draw the element. Okay, so initially this is our zero, our axis transformation. Okay, so now we are going to rotate anti-clockwise 16.8 degrees. Okay, we are now before I go on, I like to elaborate. I know now you guys are we going to draw a mini circle? No, we're not going to draw. We're not going to draw a mini circle. Okay. So we're going to draw the element. Orientate at its principal plane. Okay. So this thing is going to rotate now. Now the principal plane. Okay, the principal plane is going to rotate anti-clockwise 16.8 degrees. So I have a compass, no protractor down here. I'm eyeballing. Okay. Right. Okay. So this is rotated anti-clockwise 16.8 degrees. Okay. And then we draw our element. Okay. We sketch our element. Right. So that is 16.8. With that, right, I'm going to put in a axis down, a line down here. This line is our X line, yes or no? Right? Why is it our X line? If I zoom out, right, this line over here and this line over here are parallel, so it's our X line. Okay, and then I'm going to draw another line. and this happen to be our y, right? So why is it our y? Because if you look at this line on our element, is the same as this line orientation. Okay. Now, why is this important? From here, yes. Luis, you okay? I can't hear you, Luis. No, Luis is okay.
Actually, I have a quick question, Eugene.
Yes.
Can you explain again why that 16.8 is counterclockwise?
Okay, because, right, you see this arrow down here that I highlight in blue, yes or no? From y to the principal plane or the principal stress axis, where shear stress is 0, is rotated in an anti-clockwise direction. Yes? 5 rules.
Got it.
Okay, good. Anything stop me, okay? I don't want you to be lost. Why? Okay, now coming back to where we were before, why this point are important? Because from here, then we know if we rotate the element at its principal plane, what stress magnitude it is. Okay, so let me highlight. Okay, so over here you can see x, yes or no, right? So this is x. If we rotate by 2 theta p, we reach theta 1, yes or no? Right? We rotate the line to by 2 theta p to make sure that shear stress is 0. That is our principal stress magnitude. So from here, from x, when you rotate it, you have what? This will be your stress 2 value. So stress 2 is equal to what? We calculated, what was it? Stress 2 is equal to 46.056 megapascal. Okay, I'll do it again for the other point. Okay, so now if you look at point y, okay, point y, we're going to rotate by 2 theta p, right? So for this case, we only rotate by what? We only rotate by, this is equal to our what? Well, theta, 16.8, right? So we rotate this angle is 16.8, right? And the value reached is theta 1, which is in compression. Okay, which is a compression, and this will be equal to 26.056. Okay, so that is how you so what we just learned down here, we learned a lot of stuff down here. Okay, so what we just learned is this. Okay, what we just learned is this. We can construct, we know from element how to construct Mohr circle, and from Mohr circle how to bring everything back to the what? Bring it back to the element. And why is that? Because the element is the what? The real world. The Mohr circle is your analysis out down here. You cannot just learn Mohr circle and that's it. Okay, we are done. We are doing calculation. Yeah, we're good to go. That's what a lot of schools does. No, we have to know how to bring back from where? From the element to Mohr circle, bring it back to element to apply in the real world. Okay, I know I don't need to teach this, but it's absolutely useless if we just know the principle of Mohr circle, but we cannot apply. Okay, Marcel, yeah. Put your money in the toilet bowl. Okay, don't waste time, don't waste money. Okay. Any questions so far? Okay, I don't hear anything. We're going to do something. Okay, that a lot of time when I was undergrad, I so hate it. Right, it's like I don't know what they're asking. You know, when I was undergrad, like what are they trying to ask me? What are they trying to ask me? Okay, so we are going to do the same problem. Okay, but we're going to go further. Okay, this is like the so-called the ultimate. Okay, the ultimate in terms of, if you can do this, okay, there's no question in Mohr circle, 2D Mohr circle, that you'll be fearful about. Okay, this is like the ultimate one. Okay, it's like in Chinese kung fu, this is the ultimate battle. Okay, if you have a very powerful opponent, you just do this. Okay, the opponent will die. Okay, you will always win, like cartoon like Kung Fu Panda, for example. Right. What if now? Okay, so I will elaborate that this is going to be example number 2. And I'm going to use the same Mohr circle. That's why I copy it. Okay, so this is example number 2. Okay, same Mohr circle now. Okay, everything the same. Hey, come on, Eugene. Okay, same Mohr circle. I'm going to get rid of the center. Okay, don't worry. I just need not more than 15 minutes of your time. We go for a break. Then after the break, we come back. We do 3D Mohr circle. Okay, 3D Mohr circle is just 3 circle, not a sphere. Yeah, not a ball. We're not going to draw a ball. Okay, no, it's 3 circle. Okay, don't like, oh, we're going to do a sphere. No, don't be too excited. Right. What if now? Okay, what if now you're going to design the same structure under the same stress load, but you want to calculate what is the stresses acting on the grains of a wood, for example, okay, of a wood. You want to know what stresses are acting on the grain, okay, of the wood, okay. So the grain of the wood is at, let me see what is a good angle, is at 30 degrees. Okay, it's at 30 degrees. Okay, it's at 30 degrees, rotated in an anti-clockwise direction. Okay, you can see that from horizontal it rotates at 30 degrees. Okay, so you want to find the stress state. Okay, so you want to find, so you will label this as y30. Why y30? Because you are rotating from point y. Okay, why y30? Because it's okay. So now how do you find the stress state at y30? Okay, so you still construct, so because the stress state are the same, that's why I copy this circle. Okay, so you still construct, everything's still the same. Everything's still the same. Nothing changes. Okay, everything's still the same. Okay, you construct. So my suggestion is just sit and listen. Okay, don't copy unless you have a computer like mine. You can copy now or cut and paste. Do it. Okay. So this is okay. So we want to find, what we're trying to do is find the stress state of the element when it is rotated 30 degrees anti-clockwise from the horizontal. Okay, right. So again, I'm going to teach you element, going to Mohr circle, bring it up to the element. Same thing. Okay, we're going to still construct an element at the end of the day, but we're going to label it. Okay. So we also know the rest of value, right? So we know that our stress average, right, is equal to so the stress average did not change because I just took it from there. So the stress average is 10 megapascal, right? The shear max is equal to, wait, the shear max is equal to 36.056. Still the same. Then the principal plane 2 theta p, which is equal to, what was the angle? Hold on, do apologize. It's equal to 16.8 times 2, 33.6. So I better put down here, okay? Is it 18.6 or I forgot, what is it? 16.8, come on. 33.6 degrees. Okay, so from here, right, we're going to find y30. Okay, so note